the second worksheet based upon quadratics and discriminant topical for CIE A-Level 9709 P1 taken from the past paper questions. So the first question is solve this one 3x plus 2 equals 2 upon x minus 1. So what am I going to do that? I am going to multiply by x minus 1 on both sides so that I get rid of the denominator. So once I multiply with x minus 1, x minus 1, x minus 1 gets cancels. X times 3x is 3x square, x times 2 is 2x, negative 1 times 3x is negative 3x, and negative 1 times 2 is negative 2 equals to 2. So this becomes 3x square, negative x, negative 4 equals to 0. Now what am I going to do? I am going to do the factorization. Factors for 3 are 1 and 3, and factors for 4 are 1 and 4. So 4 and 1. So I want negative 1. So it should be negative 4 and positive 1. So it becomes 3x minus 4 times x plus 1 equals to 0. So 3x minus 4 equals to 0. X plus 1 equals to 0. X equals to 4 upon 3. X equals to negative 1. That's going to be the answer. Now coming to the next question is a completing square. X square minus 8x plus 11. We see that this is 8. 8 divided by 2 is 4. So 4 square, add 4 square and subtract 4 square. So these three terms will become x minus 4 whole square, and 11 minus 16 is negative 5. So P equals to negative 4 and Q equals to negative 5. Hence find the exact solutions of this one. So what is that equation? X squared minus 8x plus 11 equals to 1. Just now we found this one was x minus 4 whole square minus 5 equals to 1. X minus 4 whole square equals to 6. X minus 4 equals to plus or minus square root of 6 when I take square root on both sides. So one time I take negative square root 6, one time I take positive square root 6. So x equals to 4 minus square root 6, x equals to 4 plus square root 6. Next question, again completing square, 2x square minus 8x plus 14, take 2 common, x square minus 4x plus 14, then 4 divided by 2 is 2, so 2 square 4, add 4, subtract 4, so that these two terms will become x minus 2 whole square, then 2 times negative 4 is negative 8 plus 14, so what should I be able to get that one? 2 times of x minus 2 whole square plus 6. But you can see that 2 has been taken common from the entire thing. So again take 2 common, x minus 2 whole square plus 3. This is going to be the answer. Now in third question, it says that express this in the completing square form. So 4x square minus 24x plus p. So take 4 common, x square minus 6x plus p. 6. 6 divided by 2 is 3. 3 square is 9. Add 9, subtract 9. So these three terms will become x minus 3 whole square minus 9 plus p. Expand it out, 4 times of x minus 3 whole square minus 36 plus p. Next, hence or otherwise find the set of values of p for which equation has no real roots. What is the meaning of no real roots? B square minus 4ac is less than 0. So negative 24 whole square minus 4 times p is less than 0. 576 minus 16p is less than 0. Negative 16p is less than negative 576. Divide by negative 16. When you divide by negative 16, this inequality symbol changes. So p is greater than 36. That's going to be the answer. Next, 16x square minus 24x plus 10. This time instead of taking common, he is writing 4x whole square minus 2 times of 4x times of what? Plus 10. So 2 times 4 is 8. 8 times 3 So it should be 4x whole square minus 2 times of 4x times of 3. So add 3 square, subtract 3 square, and that 10 is there as it is. So that these three terms will become 4x minus 3 whole square, and 10 minus 9 is 1. So answer is 4x minus 3 whole square plus 1. It is given that this equation has exactly only one root. So one root means b square minus 4ac should be equals to 0. Okay, so 4x minus 3 whole square plus 1 should be equals to k, should have only one root. Means it should be a perfect square. So k and 1 should get cancelled. When it is possible? When k equals to 1. When k equals to 1. So that 1 will get cancelled and I get 4x minus 3 whole square equals to 0. I could able to get only one root. 4x minus 3 equals to 0. X equals to 3 upon 4. So what is the value of k? K value should be equals to 1. And what is that root? 3 upon 4 is going to be the root. Next, the functions f and g are both defined by this one. Express f of x in the standard form. So x square minus 4x plus 9. This is 4 divided by 2 is 2. So 2 square, add 4, subtract 4. So that these three terms becomes x minus 2 whole square, and 9 minus 4 is 5. Express g of x also. 2x square plus 4x plus 12. 2x square plus 4x plus 12. Take 2 entire common, x square plus 2x plus 6. Now this is 2. 2 divided by 2 is 1. 1 square is 1. Add 1 and subtract 1. So that these three terms will become x plus 1 whole square, and 6 minus 1 is 5. Next question. Express this again in the standard form. Take only 5 common. So y square minus 6y. Don't touch that, 50. Now this is 6. 6 divided by 2 is 3. So 3 square is 9. Add 9, subtract 9. So these three terms will become y minus 3 whole square minus 9 plus 50. Expand it out, y times y minus 3 whole square minus 45 plus 50. So 5 times y minus 3 whole square plus 5. Now find the set of the values has no real roots. Then no real roots. No real roots means b square minus 4ac is less than 0. So k square minus 4 times 8 times 2 is less than 0. K square minus 64 is less than 0. K plus 8 times k minus 8 is less than 0. Whenever it is less than, smaller root on left hand side, bigger root on right hand side. That's going to be the answer. Question number 6. The curve has this equation. Find the equation in this form. Take 4 common, x square plus 5x plus 6. Now this is 5. 5 divided by 2. Square is 25 upon 4. Add 25 upon 4, subtract 25 upon 4. So that those three terms will become x minus 5 upon 2 whole square minus 25 upon 4 plus 6. So 4 times of x minus 5 upon 2 whole square, multiply, it becomes negative 25 plus 16 plus 6. So it becomes 4 of x minus 5 upon 2 whole square minus 19. Hence solve this equation. This one just now we did it as 4 times of x minus, is it x minus? It is x plus, because it was plus, so x plus. X plus 5 upon 2 whole square minus 19, but is equals to 45. 4 times of x plus 5 upon 2 whole square equals to 64. Then take square root on both sides. So you'll get 2 times of x plus 5 upon 2 equals to plus minus 8. So x plus 5 upon 2 equals to plus minus 4. So one time minus, one time plus. Negative 4. 5 upon 2 equals to positive 4. So x equals to negative 4, negative 5 upon 2, which is negative 13 upon 2. Then next time x equals to 4 minus negative 5 upon 2, which is 3 upon 2. Sketch the curve showing the coordinates of the stationary point. You are not required to indicate whether the curve passes through x-axis or y-axis. So we could able to get the equation of the curve as like this: 4 times of x plus 5 upon 2 whole square minus 19. So my vertex is negative 5 upon 2 and negative 19. So negative 5 upon 2 and negative 19. So it will be approximately over here, which is negative 5 upon 2 and negative 19. X is negative and y is also negative. And to show that where it intersects the y-axis, for that what we can make it as x is 0, 0. So this will become 6. So it will intersect y-axis at 6. It's not required. Then also I have drawn it out over there. Next, solve this equation. Let root y equals to u. So it becomes 6u plus 2 upon u minus 7 equals to 0. 6u square plus 2 minus 7u equals to 0. So factorize it. Factors for 6. And factors for 2. Sorry. It will be 1 and 2 because you have to write in standard form first. Factors for 2 is 1 and 2. So 2 and 1. So that I should be getting 7. But I want negative 7. So negative 2 and negative 1. So it becomes 3u minus 2, 2u minus 1 equals to 0. So 3u minus 2 equals to 0, u equals to 2 upon 3. 2u minus 1 equals to 0, u equals to 1 upon 2. But what is u? U is square root y. Square root y equals to 1 upon 2. So y equals to squaring on both sides. So it becomes 4 upon 9. Y equals to 1 upon 4. Next question. Solve this equation. Over here, what am I going to do? Y equals to x cube. So y square will become x power 6. So it becomes 8y square plus 215y minus 27 equals to 0. So easy method is minus b plus minus square root of b square minus 4ac upon 2a. 2 times of 8. So this will give me either 1 upon 8 and negative 27. Those are the two answers for x. Y, but what is y? Y is x cube. X cube equals to 1 upon 8 or this one. So then take cube root on both sides. Cube root on both sides. So I get x equals to 1 upon 2, x equals to negative 3. Now the diagram shows the curve and a straight line. The curve crosses the x-axis at a 4, 0 and crosses this straight line b and c. Find the coordinates of b and c. So we have to equate both. So what does that becomes? 4x to the power of half minus 2x equals to 3 minus x. So 4x to the power of half minus 2x minus 3 plus x equals to 0. So it becomes 4x to the power of half minus x minus 3 equals to 0. Multiply entire thing with minus x minus 4x to the power of half plus 3 equals to 0. In that case, x to the power of half equals to u. So x equals to u square. U square minus 4u plus 3 equals to 0. Factorize it out. This is easy factorization. Equals to 0. So u minus 3 equals to 0. U minus 1 equals to 0. So u equals to 3. U equals to 1. Square root of x equals to 3. Square root of x equals to 1. So x equals to 9. X equals to 1. Now question number 2, 2x minus 3 whole square. So let 2x minus 3 whole square equals to x or y. So it becomes y minus 4 upon y minus 3 equals to 0. So y square minus 4 minus 3y equals to 0. I multiplied entire equation with y. Write in standard form, y square minus 3y minus 4 equals to 0. So y minus 4 times y plus 1 equals to 0. So y minus 4 equals to 0, y plus 1 equals to 0. So y equals to 4, y equals to negative 1. What is y? 2x minus 3 whole square equals to 4. 2x minus 3 whole square equals to negative 1. So no roots because square term cannot be negative. So only 2x minus 3 equals to square root of 4. Square root of 4 is plus minus 2. So one time I take negative 2 and one time I take positive 2. So 2x equals to negative 2 plus 3, x equals to 1 upon 2. 2x equals to 2 plus 3, x equals to 5 upon 2. I think so. This is the last question. The function where c is a constant, it is given that f of x is greater than 2 for all possible values of x. Find the set of values of x. So x square minus 6x plus c is greater than 2. X square minus 6x plus c minus 2 is greater than 0. X square minus 6x, this is nothing but what? 6. 6 divided by 2 is 3. So 3 square. Add 9, subtract 9. So is greater than 0. So these three terms will become x minus 3 whole square plus c minus 11 is greater than 0. We know that square term is always positive. Square term is always positive. So only the thing is c minus 11 also should be greater than 0. So c is greater than 11. So always square term is always positive, and I want this one, it is should be greater than 0. So c minus 11 should be greater than 0. So only possibility is c is greater than 11. So that completes our part 2 of topical based on the quadratics from P1 9709 CIE A level. That's all in this video. See you in the next video. Bye.